Good morning, students. Today I am going to explain the analog and digital communications lab. In this, the fifth experiment is pulse code modulation and demodulation. So this is the trainer kit which provides both pulse code modulation and demodulation. To observe the waveforms, I am using the digital CRO. So coming to the circuit operation, in the pulse code modulation, we need analog signals as a message and pulse signal as a carrier. So these two signals are given to the analog to digital converter. So the output of the analog to digital converter is in the form of digital signals, zeros and ones, so which is called digital signal format. So here the pulse code modulation will convert the analog signal to digital signal. So that is the operation of the pulse code modulation. So the output of the pulse code modulation again given to the demodulation circuit, simply digital to analog converter. So in the digital to analog converter, the digital data which is transmitted from the transmitter is given as an input, and we are observing the output at demodulated signal, that is in the form of analog signal. So to start the experiment, I am using the clock signal with 1.5 megahertz. So here we are having the provision with number of clock signals as 4 values with different frequencies: 1.5 megahertz, 3 megahertz and 6 megahertz and 12 megahertz. So for our convenience, I am using the 1.5 megahertz. So to observe the output of the 1.5 megahertz, I am connecting the CRO positive knob to this clock source 1.5 megahertz. So this will give the signal on the CRO. So to understand this pulse signal, change the horizontal knob. It will give the pulse formation of the clock signal. So this is the 1.5 megahertz clock signal. So now I am giving this 1.5 megahertz clock signal to the sample rate generator. So this, from the clock signal to sample rate generator, I am connecting the circuit with a patch cord. So from 1.5 kilohertz to megahertz to system clock generator. Then I am using the AC source as a message signal. So here I am connecting the positive knob of the CRO to the AC source, which will give the amplitude of the message signal and time period of the message signal. So this is the AC signal I am getting from the AC source, simply acts as a message signal. So this message is given to the V input of the L and R of the trainer kit. So this will give the analog to digital converter. So for this purpose, I am using the patch cords from output of the AC source to R and L pin input signals. So these two are connected like this. So this is the input connection, and to observe the output, we are using the serial data interface from the analog digital converter to output. So for this serial data input also we need two input signals. Those are channel clock and bit clock. So to connect channel clock and bit clock, I am using the sample rate generator. So this is the channel clock and this one is the bit clock. So these two are the two input signals, provides the control signals to the serial data interface. So at the output of the serial data interface, we are getting the digital data, which is our required pulse code modulated signal. So I am connecting the CRO knob to the digital data output. So that is available on the screen. So for the decreasing of the amplitude, I am considering the digital data as 0. Increasing of the amplitude, we are considering the data as 1. So this is the PCM signal observed in the PCM modulated trainer kit. So to get the demodulated signal, so connect this D output serial data interface to serial data interface in the receiver. So like this. So D output to D input. So I am connecting here, and observe the digital to analog converter output at any output of the L and R. So that is available on the screen. We can adjust the horizontal knob, will get the sinusoidal recovered message signal. So the frequency of this demodulated signal is nearer to the AC source, that means which is available in the transmitter. So that is the message signal frequency is nearer to the demodulated signal. That is called recovered message signal in the receiver. So this is the PCM experiment. Thank you.